Hey guys, it's Vince. Today in this video, we are going to be clearing the air and once and for all determining which motion control software is the fastest. Rick Perry just did another video. He was the past client that migrated over from Mach3 to Pumotix. He documented it, and the last video he did was on a 60/40, and he showed the difference in speed he was able to achieve with Pumotix, which floored Mach3. Well, of course, after he posted that video, there was a bunch of comments saying, hey, tweak this in Mach3, you can do this, you can do that. The software shouldn't be actually affecting the performance of the system, which is a direct misconception. Your motion control software is, without a doubt, the defining governor of your actual system. If it will not allow the system to get the maximum range that is available in terms of the hertz rating of the controller being used, you will soon find, and I'm going to define it in this video live, that your software controls everything in terms of speed. So that being said, we've got our old trusty setup. Here's the PLCM E1B from Pumotix. This is the newest release in terms of what I've released. This is my beta version. Here is the UC100. It's running at 100 hertz. Gecko G540 system, all of you are familiar with. This is the same system I sold for many years now. This is actually my Rev 3 model with the new power supply release. I disconnected the fan so you guys can hear me talk as I turn on the system. I've had requests for that so I can make this explicitly clear. This camera is shooting in 4K right now, so everything should be right on point. First thing I'm going to do is power up the system. UC100 is already plugged in. I'm going to go into Mach3. I'm going to cover the basics. Got the UC100 connected. You see here I'm selecting it in Mach3. Now I'm going to reset. Okay. First thing I want to cover is Rick's settings in the new video. Okay. The steps in Mach are steps per inch in his measurement matrix is set to 400. Now, for those of you that don't understand how this works, very simple. We've got steps per inch. That means it's 400 he has set to equal 1 inch. That simply means that it only takes very minimal rotation of this shaft of this motor to equal 1 inch. In the previous video, he had his steps per set to 1 inch measurement at 10,160. That means there's a greater rotational factor of the motor required to equal the same distance. The lower this number is, the smaller amount of movement the motor shaft is required to move the same distance. And this will become prevalent as we go through this. However, you can see right here, steps per is set at 400, velocity is set at 3750, acceleration is set at 500. His G-force, and I want you to pay close attention to this, is set at 0.05. Step pulse setting at 2, direction pulse setting at 2, and this is for the x-axis, okay? Now that we're all on the same page on this, let's come over to my settings and see what we got here. Once again, he is running at 25 hertz, and I'm going to even show you that too. I'm running at 25,000 hertz, okay? I'm going to click OK. I'm going to come over here to config. We'll go into motor tuning, make sure everything is matched. Steps per 400. Velocity set at 3750. Acceleration at 500. Now remember I told you to pay attention to the G's? Well, it's interesting. My G's represent at 1.29. His G's don't represent that. Why? I don't know. Here's another point. How many of you paid attention to his grid? His grid was all the way up in a very, very high arc. Mine is not. Wonder why that is. We don't have that on this either. Now, of course, my laptop is an ASUS. It's an i7 with 32 gigs of memory, dual solid-state drives. I mean, again, the horsepower of the PC, in theory, should not matter if we're talking about motion control. So, again, let's take all that out of the mix, because I hear that all the time. And come back into Mach3. And now you can see where I'm at in settings. X-axis I'm on. I'm going to select OK. We're going to jog the motor and see what happens. And I want you to pay close attention once again to the feed rate. We should hit, in theory, the 3750. You see the motor spinning here, and I can tell you right now, many of you out there that have experience with Mach3 in motion understand that at 3,750 inches a minute, this motor isn't even close to that under most systems. But yet, if we look up here at the DROs, we're at already over 900 inches. Now we're at 1,000 inches. Why is that? Well, once again, if we think about it, if we're only saying 400 steps equal 1 inch, that's tiny as far as movement of the motor shaft to equate to 1 inch of measurement. However, if we decide to go like most systems and use ball screws, he's at 10,160 in his first video. That means his motor shaft has to spin much more in terms of revolution to equivalent to the same distance. That's why you see this number greatly changed from where it was when we go to 10,160. You would see the same in terms of it going back. So I'm going to hit go to 0. Okay. Now that we've seen the motion of the system, and Rick made it abundantly clear that if he decided to change any of the settings he had in Mach 3 in this last video he posted, his system wouldn't allow it. Okay, so let's see if I run into the same problem. Okay, config, motor tuning. Okay, at this steps per setting, his inches per minute, as far as being calculated up to 100 hertz, which is the maximum this hardware will support, would equivalent to 15,000 inches a minute. In theory, he should be able to achieve that. Now, if you want to check my math, that's fine. You don't believe it, that's cool. We'll check it when we go into Pumotix because it's going to define it for you. But either way, if I go to 15,000, watch what happens here. The software set me at 12,750. So many of you are saying, oh, that's because your hertz rating is set at 25,000. No, it's not. And I'm going to show you that. So what you're going to see here, we'll leave it at 12,750. Okay, that's still higher than what Rick was able to achieve. My G-force still has not changed, but look at my arc now. Kind of crazy, right? Right. It's supposed to be representing all this extra speed. Well, let's see what happens here. Save axis settings. Now we're going to hear the motor spin up. Once again, our feed rate is now represented at 12,753 to be exact. You can see how the motor is spinning. Definitely hear a pitch change in it. Okay. You can see here that, once again, we're covering a lot of inches fast. Now I'm going to hit go to 0. So many of you out there that are saying, well, you're saying it can go to 15,000. The reason that's not possible for it to hit 15,000 inches a minute, if that would equal 100 hertz, is because you don't have the settings in Mach 3 configured on the ports and pins for a kernel speed of 100 hertz. So I say, let's test it. Okay, apply. Now I'm going to hit reset, and I'm going to exit out of the software. We're not going to pull any punches. We want to see the truth, right? Right. Mach 3. UC 100. Motors have holding torque. Everything is set. Let's double check, make sure our settings are confined correctly. Once again, we're at a max of 12,750. Everything here is not changed. Let's try to go to 50, or actually we'll do it after. We'll go back. We'll go back into config. We'll go to ports and pins. We are now set at 100 kilohertz. So as Mach 3 sees it, we should be at the maximum setting. Let's double check our plugin on our UC100 to make sure we're at 100 kilohertz there. Okay, so our software and our hardware, everything is corresponding. There is no way to set a G540 at its max hertz rating at 100 hertz. I can tell you that as being a Gecko dealer. If you don't believe me, you can contact Marcus over at Gecko and find out if I'm correct. It's autonomously set up for that. What you see here is everything is matched now at the maximum frequency. I never touched this. We've seen this when I first started the video. It was set at 100 hertz to begin with. So the UC100 is set correctly. Everything here is set for maximum speed. In theory, if I go back into motor tuning, I should be able to go higher than 12,750, right? Right. Let's see. I'm at 15,000. Watch carefully. You focused? Mm-hmm. Good. Just bounces back to 12,750, gentlemen. Now, for the software guys out there who have been giving all of this feedback, and you're probably wondering, why does it keep bouncing us back to 12,750? Good question. I wish I could answer that. I can't. What I can answer is that Mach 3 does not allow the maximum performance of your system, for whatever reason that may be. We see a consistency difference on these numbers right here, that how come I can achieve past 3750 and I can run my software? He can't. I can't explain it. Can it be because it's connected to his chassis? Absolutely. He could disconnect it and try it. But there's more prevalent things here going on, and I want to show you that. Okay, I'm just closing that out. We'll come back in. So we know now Mach will not allow us to achieve past 12,750. So now that we know that, I'm just going to hit save. I'm going to come over here, and you can see again, we're hitting 12,750. Okay, Rick on his system was only able to hit like 150 I think 147 inches. Okay, but right now we're hitting it. You can see once again the maximum range that we're getting with the inch count. Now I'm going to go to 0. Now we've all witnessed this. Everything here is set the same. I'm going to do it live. I've got the PLCM plugged in, so I don't even have to mess with that. You can see the LEDs on it, ready to go. I'm just going to turn the system off, cycle it over, and turn it in so you can see the exact same thing done with Pumotix. I'm cycling off my controller now. She'll see the LED, powering it down. This is the proper way to switch if you were ever doing that. Here's the UC100 once again. I'm going to unplug it from my system. You can see it. No funny business. Now, let's come over here. Plugged in. Everything here is set. PLCM is plugged in. I'm going to plug in the Ethernet. Make sure we have full communication with the laptop. Okay, magic. Here we go. Power on the system. On. Holding torque now is prevalent to our motors. Coming into Pumotix. Okay, I'm going to go with 9-axis screen set. Now I'm going to leave off my soft limit. You can see up here, I've got my soft limit off for the x-axis, and I'll show you why as we go through this, because I told you I'd explain all that as far as movement and measurement. Now I'm going to come over here to configuration settings. Here she is. We'll switch over. Go apply. It's updating the data. That's done. Let's do it again so we make sure all our numbers are accurate. Okay. Once again, put it at 400. The software is going to auto-calculate. Velocity 12,750. Acceleration 500. Steps frequency, we were only at 85% or 85 hertz out of 100. We know we're still leaving 15% on the table. So, is this software faster? Let's find out. Let's find out. Let's see if I can go to 15,000. That's what I told you before, right? Now I'm at 100 hertz. Here's 15,000. I'm leaving the acceleration the same. Clicking apply. Click OK. Turn the console on. You guys ready? Watch. Watch here on your rapids. Watch carefully. Look at that motor. Big difference, right, gentlemen? Rapid rate, 15,000. And this is done live. Everything you're seeing, there's nothing here that I'm changing or manipulating. I'm showing you exact, step for step. Everything is set the same. Why is Mach doing something differently? Doesn't make any sense. Doesn't make any sense, guys. We're leaving performance on the table. Now, whether or not you understand the software or not is really irrelevant. The bottom line is you don't really have to understand it to see what's right in front of you. The software is broken down to show you, once again, the operational envelope. Max step frequency, and that's using a PLCM, is 100 hertz. With the G540, it's 100 as well. If the G540 could exceed 100 hertz, you still wouldn't be able to go past what this controller is able to actually achieve. You can see our steps per unit actually adjusted by a few decimals, but we're running a velocity at 15,000 inches a minute. Now that's fictitious. His acceleration is still set at 500. Either way, we just increased our speed by 15%. Okay? But, here's what's interesting. If we come over here, we'll leave this, we'll go back to his 12,750. We'll be at his same settings, okay? And here's why I turned off soft limits. I'm just applying everything. If I turn my soft limit on, I want to show you this table is fictitiously set at 20 inches in terms of the dimensional aspect for my soft limit to become active. Watch how small a distance this stepper at that setting of 400 steps per inch has to rotate to actually hit the soft limit. Watch this. We'll turn on our console. Look. Watch carefully. That's it. This software is calculating. There's your soft limit at 20 inches. Look at this. Watch the motor now. Pan on the motor. Let them see it. That's it. That's at 400 steps. There's your 20 inches of travel. Okay? Because when we go once again to 10,160, which is where he started, and I'll show it to you right here, you'll see the difference of how many rotations this motor has to go through to actually achieve the saved distance. So let's do that. Watch this. settings, axis. And you'll notice something else. If I come in here and go to 10,016, excuse me, if I come over here and I try to change this, there we go. We're going to go to steps per. We're going to go velocity. Let's go 585. Now, if you look, I'm at 99 hertz at 585 inches a minute. Okay? Rick wasn't even close to that. I think he's running 147, I think we said. We're at 585. I believe he can go 0.5. Actually, he probably could go 586 maybe. Yeah, 589. Let's try 589. Okay, so we can achieve 589.5, which puts us at 99.822 hertz. You want optimal speed? I'm going to give it to you. You will not be able to achieve an acceleration of 500. And the reason why is the motor will stall. And it's because it's such high acceleration. If you want to test that, let's test it. I'll show it to you. Turn it on. There's your motor stalling. See the G-force, how the motor is shaking? That's G-force from acceleration. Okay? Now, this is what happens when a stepper motor stalls. So what we're going to do, we know we can't achieve that speed. We're going to turn this off. We're going to come into configuration settings. And now what we're going to do is adjust it so our acceleration is feasible. Let's go to 50. That sounds good. Well, we'll even go back to his original speed of acceleration was 25 in that previous video. Not the one he just made, the one that we discussed when he said he had the fastest 60/40 instead of 25. Now watch. Come over here, go to 0. Big difference, huh? Sounds good. Let's see. 589 inches a minute. That's how fast she hits 20 inches when we got soft limits. You notice she's coming to a break by herself. Once again, Pumotix is doing all the math. There's no soft zone. Look here carefully at the rapid rate so we know we're all on the same page. This is saying 589. Now she brakes, and there you go. Okay? Let me show you how advanced this is. If we go to 0, okay, she hit 0 again. We're going to turn this off, the soft limit. And we're going to go to our, we'll go turn off the console. We'll come into configuration. We'll go settings, axis. I want to show you guys the truest definition of G-force. If you accelerate too fast, all of the G-force, and I talk about this all the time, will be transferred to your chassis. This is what you want to avoid. If we go to 75 per se, we go OK, hit apply on acceleration. Now we're really boogieing. That means naturally the faster the motor is going to accelerate. Again, it's going to be fighting its own torque. We're updating our data. Click OK. Turn on our console. Okay, watch the difference. Watch how the motor reacts when I go to jog it. You see how it's shaking? Watch. Look at that initial shake. That's G-force. That's all that torque, no different than if you stomped on the gas in your vehicle when you go to peel out. That's what's happening. And that excess energy is being dissipated in your chassis. There is nowhere for it to go. So that's why we always want to have a smooth increase in speed. As far as speed goes, I don't think anyone will argue this is kicking the piss out of Mach 3. Okay? So now that we're all on the same page here, I hit go to 0. You've seen how fast that was. Watch this. We'll do it again. Go to 0. Dead on. Okay? So again, we've seen now the difference in acceleration and that type of performance. We've seen G-force in action and what we don't want to, or what we want to avoid on our system. But let's do this. You can see here the steps per unit. I turned it to 160, and you see the difference in the amount of travel when it's set to that in comparison to when it's set at 400, like it was in his previous video. Either way, though, in either format, his speed is a massive, massive difference. And now whether or not he's able to achieve this full speed is negligible based on the chassis, based on his calibration. Rapids only count, and the speed only counts if accuracy is present. But without a doubt, this software hands down destroyed Mach 3. And you can see exactly what we're talking about here in the number factor. If I go up to 100 on acceleration, now we've just increased our acceleration that much faster to go to that 589 inches a minute. Watch this. You'll see that differential in G-force become prevalent very quickly. Turn on the actual system. You ready? Watch the motor. Look at how fast. Look at that torque. There you go. That's what 600 ounces, 37.5 inch-pounds of torque will do instantaneously. Okay? That's what's happening, guys, when you're doing this, and these are bolted to your chassis, and you're actually putting the acceleration too high. What we're really looking for is that sweet spot. And I'll show you that real quick. Usually it's about 25 to 30. Turn off the console. I'm going to go configuration, go to settings, go to axis. You see how fast this is. It's ridiculous. We'll come over here, go to acceleration, and we were at 25. Let's go to like 30. Or even better yet, let's go 35. At that same speed, what I'm going to do, I'm going to put some container of water. This is always a fun test to do because the water will show you definitively what kind of force is being exerted through the motor and also come over here as resonance. And that'll give you a visualization as far as what excess force is playing on the motor and also on your chassis. So check this out. We're going to go apply, let the data update, turn on our system. Now you'll see a big difference. You'll notice a slight jar in the motor as she's coming to a brake. We're going to accelerate and then come down, and then it stops. As that motor is moving though, you see nothing. Okay? Now let's see, because this is a cool example. How much time I got left?
About 8 minutes.
8 minutes? I got to make this quick. I want to show you just how advanced this software is. Okay? Coming back to home. Turn it off, come to configuration, go to settings. Let's see if this software can be tricked. Because Mach will only allow certain things. Let's put in an arbitrary number. We were at 400 steps per unit. Let's go down to 100. How about that? If I go down to 100, look at my steps frequency. I'm only at 0.98. I'm not even at 1. I'm not running at 1 out of 100. Now watch this. That means my velocity, I could turn this way up. And matter of fact, if you decide to exceed something, you can see the software will tell you your maximum. Max steps frequency exceeded. The parameter value cannot be greater than 60,000. You think Mach 3 is going to allow that? I don't think so. But I can tell you, let me just make sure I hit that on the keyboard. There we go. 60,000. Now you're at 100 hertz. We're going to accelerate it at, let's go at 50. Just want to show you this because I don't have much time. Watch this. Done? Ready? Watch your feed rate. Watch your measurement. We'll pan in everywhere and listen to the motor. Look at how she starts accelerating. See how slow it is? Once again, we're ramping up, gentlemen. Sounds like a turbine. Get ready. Get ready. That's 60,000. Look at that count. At 100 steps per unit measurement per inch. Mach 3 isn't even close, and I can tell you that. When I tell you I've worked long and hard on this with those engineers, those guys really worked hard, and this is pretty amazing what you're seeing. You can hear the braking coming into play, and we're in. Okay, so let's see. That's at 60,000. What if we went down to 50 steps per unit? In theory, this should go even faster, right? Right. Let's see. Here, watch this. Let's go down. We'll go down to a steps per unit measurement per inch of 50. Okay, we're going to go 50. That means we've just doubled that. We should have a velocity of 120,000 available to hit 100. There's my numbers. I'm going to accelerate at 100, and the reason I'm doing that is so that we can get there much quicker. Actually, we could probably go even more than that because now we're moving at a much slower rate. Let's go 500. We'll see what happens. Hit apply. So once again, I'm velocity 120,000 inches a minute. Why is that achievable? Because our steps per unit is only at 50 steps per inch. So again, we'll hit apply. Get ready for it. Go to 0. So again, you can hear the difference in the tone of the motor. You can hear the acceleration change. She's doing all of the math. She's coming back down. You hear her slow down. There it goes. Done. Okay? So again, I think I've made myself totally clear. I don't think there's any smoke and mirrors. You watch this in a completely unedited cut. This is from point A to point B, comparing them both. I've explained now the differential between using smaller steps per unit measurements versus larger steps per unit measurements, and now you can see definitively which software is faster with either of the settings. In this software, you run at 100 Hertz based on what your settings are as far as your axis, and that's why that operational envelope is put there, so you know exactly what you're running in comparison to what your hardware is. If I didn't want to run this, and let's say we went back to 60,
3 minutes.
okay, I got 3 minutes left. You can see I'm at half, and that'd be 50 Hertz under 100. So you see you're running at half at 60,000. The software is doing all of the math. Of course, it will not let your motor out accelerate it. It's impossible. It's working with the software. So for anyone having questions on whether or not the software controls your system, I think we've answered everything. You can see how everything is set. And once again, I know many videos will make you have more and more questions. Overall, I think this is the most definitive example of what you can see of what's going on. Now, of course, it's not connected to a chassis, but you see exactly what's happening. So again, guys, if you have questions, require quotes, message me direct at storm2313@gmail.com. You can message me through my eBay store. Pumotix right now, as far as my PLCM E1Bs are sold out. I have another order coming in, and this is why it's sold out. It's cheaper, it includes the software, and again, this is what you're getting. You're not going to get the 9-axis screen set and all the additional modules, but again, the performance is there. So again, I'm putting my contact information at the beginning of the video and at the end. I hope this has been helpful. I have to go. To all my subscribers, I love you guys. Take care.